Well, it is a rainy afternoon in Point Lookout, Missouri. My name is Dr. Klein, and I want to welcome you to Calculus 1. I wanted to take a few minutes and talk about the history and background of calculus. I would like to give you some sense of what the essence of calculus is all about. And at the end of the video, I'll just mention briefly some of the ways that calculus is used today. So let's get started. So the word calculus comes from the Latin word for pebble. Pebbles are used for counting or calculating. In the past, the word calculus would have been used the same way we use the word mathematics. They were sort of used interchangeably. But of course, now when we say calculus, we mean a specific branch of mathematics. I listened to a talk once where the speaker pointed out that many areas of mathematics can be described by one word. He pointed out that geometry you could describe with the word shape. Geometry is the study of shape. Algebra, you could say, is the study of relationship. Probability, you could say, is the study of chance. And so, of course, that begs the question, what one word would describe calculus? And the word is change. In its essence, calculus is the study of change. It has two main branches. There's differential calculus and integral calculus. And we'll look at both of those this semester, although we'll spend the majority of our time studying differential calculus. We'll see towards the end of the semester how those two branches of calculus connect, how they relate when we look at the fundamental theorem of calculus. Theorem is just a mathematical truth that has been deduced or proven from previously known or assumed facts. Calculus as we know it is generally credited to being discovered by Newton, Isaac Newton, and Gottfried Leibniz. But there are many more people involved in the story of calculus than just those two. For example, the French mathematician Pierre Fermat was heavily involved. Archimedes, all the way back to the 200 BC, even though he was not doing calculus as we know it today, it is widely accepted that he was thinking about things from a calculus perspective. So what is that? What is the essence of calculus? We said it's the study of change, but at the heartbeat of calculus, the basic idea that you'll see again and again and again is to take a complicated problem that you can't solve and break it up into a bunch of little pieces that you can solve, and then somehow put all those little pieces back together to get the answer to the big problem that you couldn't solve. That's what calculus is really about. I was working this summer on my house, and we wanted to get rid of an old handicap ramp that we didn't need anymore. It was kind of rotten, and put in some stairs, but there was a massive boulder in the way. And it was way too big for me to move. So I got out my sledgehammer and a chisel and a big pry bar, and I took that big boulder that I couldn't pick up, and I broke it into lots of little boulders that I could pick up. And that's kind of an example of how we're going to do calculus. Although calculus would say you need to break the boulder up and then move it and then put them all back together again to get the original boulder back, which I couldn't do. The catch with calculus, though, is unlike me breaking the boulder up, I broke the boulder up into a finite number of pieces. Calculus, when we break up a hard problem into smaller pieces, we generally break it up into infinitely many pieces. And of course, whenever infinity is involved, things can get out of hand very quickly. So we need to be very careful how we do things. And we're going to spend some time developing a language that will let us do that carefully and correctly. So I'll end just by mentioning some of the many applications of calculus. People who discovered calculus, like Newton, were extremely interested in how calculus modeled the motion of planets. So there's been all kinds of interest in calculus in the natural world around us. As Galileo said, the language of the universe is mathematics, and calculus is a huge part of that. But even modern technology, cell phones, televisions, your GPS, ultrasounds, unraveling DNA, finding Neptune, using your MP3 files on your phone, a huge breakthrough in the fight against HIV. All of these things rely on calculus techniques. And so I'm not going to spend a ton of time this semester focusing on application. We will do some, and I'll certainly mention it as we have time. But for those of you that are interested in more of the application side, how does calculus apply to the world around me, then I would highly recommend this book to you. This is called Infinite Powers, and it's a very friendly read on what calculus is and how it's used in the world around us. So not required for the course, simply if you're interested, then I would encourage you to get a copy. I'm going to ask the library to have a couple of copies on hand this fall, if at all possible. So that's a brief introduction to calculus. In the next video, we'll start our study of calculus by looking at functions.